Hey guys, yeah, today we will learn about resonance frequency. So this is if you guys understand the LC circuit properly, and this is the same concept of switching surging. Let's see. So as I explained already, in the LC circuit, transient response happened, right? Because L and C has a different energy. So that's why they give and back, give and come back like that. So that's why the vibration happened. And let's quick review about to make the dielectric breakdown or insulation damage, same meaning. So it calls the three variable part. Voltage is magnitude, voltage is duration time, and voltage is slope. So which means that today is the frequency, the slope. Slope is, as you guys know, slope, right? It's connected to the frequency. But first of all, we need to quick review about the previous lecture. Let's move on. Here. So there's LC component. If there happened, I said this swing, the vibration, it just happened naturally, right? So I explained it this example, right? The way it's moving, right? So C is, I said this is a potential energy, C is, and L is the current is moving, right? So kinetic energy, but totally different. But what I mean is, since they are different, they are like a vibration, but in some point, they gotta be the same, frequency they have. We say this is resonance frequency, okay? So let's see. First of all, as you guys know, L, it's coil, right? And C is a capacitor, for example. So it gotta be start from the infinite ohm, right? It's insulation. Dielectric is the same material as insulator, right? So it gotta be infinite ohm, almost. And the copper is 0 ohm, right? You guys remember. So which means QL and QC, it gotta be equal. What I mean is, so XL V22, XC V22. It gotta be equal, as we say, today's lecture resonance frequency, right? So if we we will deeply learn a little bit. So QL is gonna be omega L, and the QC is omega C1, right? So it could change it. The omega is 2 pi f. So angular velocity, right? 2 pi f L, and this is 2 pi f C. So which means L is proportional to the frequency. So frequency is up, the L's inductance is up, but instead the C, it's a non-proportional, right? Frequency is up, which means that the C is gonna be down, totally different. But at some point, look at this is L, this is 0, and C is here, infinite, right? So depending on the frequency, right? So because of the frequency value, it gotta be, if it's up, the C is down. If the frequency up, L is up, right? We meet at some point. When it's the same point, that's it. We say the frequency, resonance frequency. Let's move on here. So what I mean is, this is the resonance frequency formula. So which means Ln, XL and XC, L and C, they are totally different component, right? When they are same, we say this is resonance frequency at some point, right? But as I said, this is L in inductor is starting from the 0 ohm. It's Cooper, right? And C is insulator or dielectric. It says it starts from the infinite ohms. but some point it gotta be same point. You know what I mean? Some specific frequency they have with the resonance frequency. So for example, this is a good example. You know, we have a laundry machine, right? So sometimes we can see the laundry machines, you know, shaking really hardly. Why it happened? Because, you know, the shaking machine, it has its own, I know, the laundry machine, it has its own frequency, right? And inside of the laundry machine, there's also cloth, right? Cloth, when it moves, also it has its own frequency, right? But for example, in dehydrate, you know, remove the water from the cloth. So that time, when it started dehydrate, so the machine spins really hard, right? The cloth is also spinning, but they are different. You know what I mean? Speed. So it doesn't matter. But what I mean is, for example, almost at the end of the dehydrate, the machine's its own frequency, and in the machine, it's also the cloth is spinning, right? Its own frequencies is sometimes it gotta be same. So which means it make amplitude. What I mean is, if the amplitude same, you know, frequency, we say this is it occurred like resonance happened. Resonance happened. We say because they are totally different frequency, but they are gotta be the same. So it making more double like amplitude. You know what I mean? So that's why sometimes at almost at the end of the laundry time, the machines are sometimes, you know, shaking, vibration, you know what I mean? So to reduce the frequency, you know, resonance frequency, as you guys know here, I indicate this picture. So this side, you know, plate, there's just some shape, right? So it's not just a decoration because it reduces also, you know, resonance frequency, like vibration. It reduces the, I mean, it's not reduces the frequency. What I mean is it reduces the vibration. It's not just decoration. There's purpose. You know what I mean? Yeah. So what I mean is, let's quick review. Frequency, resonance frequency happened because L and C, they are different components, right? But they need to do give and return it back the energy. That's why the vibration happened. What I mean is, you know what I mean? Like from potential energy to kinetic energy, same meaning. Like it happened, but at some point when they are staying together, you know, the frequency is the same. We say resonance frequency, right? And like for example, laundry machine, if they have a you know totally different frequencies make it same, it make it amplitude. That's why it make it more you know vibration. That's it today's lecture.